Hello everyone, welcome to my chemistry channel BL Das, short and sweet in chemistry. Now I am going to explain the distinction between alkane, alkene and alkyne. What is alkane, alkene, alkyne we know in the chapter of alkane, alkene, alkyne in 11th class. Now the question arises, what is the distinction between alkane, alkene and alkyne? There are so many physical properties, so many chemical properties in alkane, alkene, alkyne, and different type of hybridization exists in alkane, alkene, alkyne. That is why we can differentiate, we can distinguish between alkane, alkene, alkyne. Now see here alkane, alkene, alkyne. Then what is the general formula of alkane, alkene, alkyne? CnH2n plus 2 that is for alkane. CnH2n alkene and CnH2n minus 2 that is alkyne. What is N? N is the number of hydrogen, N is the number of carbon, and H2 and 2N, that here if you will put 1, then here 2 into 1, 2 plus 2, 4, methane, the first compound, that is methane. Similarly, here C2H4, that is ethene, here C2H2, ethine. And so here you can say this is saturated hydrocarbon because there is no double or triple bond here. Alkane is simply saturated hydrocarbon, and this one alkene, that is unsaturated hydrocarbon, and alkyne also unsaturated hydrocarbon. Then how can you know this is saturated, unsaturated, unsaturated? This is indicating by the bonds. The bond, whether it double or triple or single. See here, if it is single bond, then saturated hydrocarbon means alkane. In double bond, that is unsaturated means maybe alkene, maybe alkyne, or that means it depends on bond, double bond and triple bond. If it is double bond, then it is alkane. If it is triple bond, then it is alkyne. Now here if you burn that alkane, alkene and alkyne, they are giving different type of flame. One is called sooty flame, that means unburned carbon particles are evolved, that means black smoke evolved. So no sooty flame, that means here this alkane is a saturated hydrocarbon, so it burns completely and that is no sooty flame. But here alkene containing double bond and unsaturated hydrocarbon, it will not burn completely, so it gives sooty flame, that means carbon particles with black smoke. Similarly, alkyne also, it is a triple bond and unsaturated hydrocarbon, that is why it gives sooty flame. Sooty flame means black smokes. And it undergoes which one? Alkane undergoes sp3 hybridization, and similarly alkene undergoes sp2 hybridization, and here alkyne undergoes sp hybridization. When we will see this chapter alkane, alkene, alkyne individually, at that time we can see, we can observe what are the hybridization here in alkane, alkene, alkyne. Again remember, alkane sp3 hybridization and alkene sp2 and alkyne sp hybridization. That means here sp, that means same proportion of this is orbital sp orbitals here, and this is sp3 orbitals and here sp2 orbital and undergoes hybridization. So these are called sp3, sp and sp hybridization and sp hybrid orbital. And you can find example if it is ethane, ethane formula C2H6, Now it contains single bond, and sp3, this carbon undergoes sp3 hybridization, this undergoes sp3 hybridization. So HH3H, this is attached to this carbon, and 3H attached to this carbon. Similarly, sp2 hybridization, this carbon attached to these two, and this carbon attached to these two, and here this double bond, that is sp2 hybridization undergoes this carbon and this carbon, and here sp hybridization, see it is ethine. Ethine means C attached to hydrogen and the C attached to hydrogen, and now in middle of carbon and carbon there are three bonds, that is called triple bond, and that is sp hybridization, and that is why in each orbital that is called sp hybrid orbital, this one and this one. But here it is one is sp hybrid orbital, other one also sp hybrid orbital. Now here difference is that sp of carbon and s of hydrogen overlapping, and here sp of carbon overlapping. Similarly here carbon sp2 carbon and s of hydrogen overlapping, these two also same. In middle sp2 of carbon and sp2 of this carbon overlapping, that is why two bonds and three bonds and single bond present, and this is saturated hydrocarbon, it indicates unsaturated, and unsaturated also alkyne and alkene respectively. Then we will see other chemical properties. How can you distinguish between alkane, alkene and alkyne? Now you can see here some chemical reactions of alkane, alkene and alkyne, where we can distinguish between three the compounds, hydrocarbons, that is alkane, alkene, alkyne. Now see alkane CnS2n plus 2, alkene CnS2n, and alkyne is CnS2n plus minus 2. And now hydrogen, here no reaction because there is no double or triple bond, all are single bonds. And similarly alkene contains double bond, that is why hydrogen react, it gives alkane. Similarly alkyne, when react with hydrogen, it gives alkene. See again, alkane no reaction, alkene react with hydrogen gives alkane, and alkyne react with hydrogen gives alkene. That means if hydrogen is added, then the double and triple bond gradually decreases. Now bromine and carbon tetrachloride, no reaction because again alkane contains no double or triple bond, it contains single bond, it is called paraffins, inactive, so no reaction. But alkene, that is decolorized, and alkyne also decolorized. Bromine, that is added in, that is to hydrogen, hydrogen is replaced, and so what happened, it gives dibromo derivative. Why? Because there are two hydrogen, that is why it is dibromo derivative, whereas there are double bond, here double bond and here alkyne triple bond, so here 4 hydrogen replaced by 4 bromine, the reaction you know in alkane and alkyne chapters. So here it gives dibromo derivative in alkane and tetrabromo derivative in alkyne. Then comes to alkaline KMnO4. Then question is, what is the color of KMnO4? Pink color. What is alkaline? That means alkali is added, potassium hydroxide or sodium hydroxide is added, and that is called Bayer's reagent. Again here in alkane there is no reaction, but in alkene that is decolorized, that means pink color is decolorized because here double bond is there, double bond will unsaturated hydrocarbon, that is decolorize this reaction, that is alkaline KMnO4, which is pink color. Similarly alkyne also decolorized, that is Bayer's reagent, which is alkaline KMnO4. Alkaline KMnO4 means pink color. And ammonical silver nitrate means silver nitrate solution is make a solution with our ammonia, that is called ammonical silver nitrate solution, and here in alkane no reaction, in alkene also no reaction, but specially in our alkyne, that is ethyne, has reaction. Now ethyne react with silver nitrate and ammonium hydride, then ammonium hydroxide, then what is the product we will see. Again see alkaline KMnO4, in alkane no reaction, in alkene decolorizes and alkyne decolorizes. And ammonical silver nitrate no reaction, here also no reaction, but in alkyne especially ethyne react with silver nitrate and ammonium hydroxide. I told ammonical silver nitrate, that means silver nitrate with ammonium hydroxide, then it gives white precipitate. What is the reaction we will see. Here you are sure that the alkyne react with ammonical silver nitrate, that is why you can write this is called ethyne react with silver nitrate and ammonium hydroxide, it gives silver acetylide. That means here the silver, two silvers are attached to carbon having triple bond, that color is white and precipitate. The byproduct are ammonium nitrate and water. Again see silver acetylide, that is white precipitate. Ammonical that is cuprous chloride. Here it is cuprous chloride, and here alkane has no reaction, alkene also no reaction, but alkyne has reaction. And now you can see the acetylene, or you can call that is ethyne react with the cuprous chloride. The formula remember Cu2Cl2. In presence of ammonium hydroxide, it gives here that copper acetylide, that color is red precipitate, ammonium chloride and water. Again see here the copper acetylide you are getting the red precipitate, whereas alkene they will never react with ammonical cuprous chloride. I hope the reactions involved in alkane and alkyne, how can you differentiate, how can you distinguish between three, and these are the sufficient reaction, chemical reaction, and also I told what are the main physical properties in these three chapters, in three compounds. I hope it is clear to you, and hope you will subscribe my channel BL Das, short and sweet in chemistry, and thanks for watching my video. Thank you again to all.